Hello YouTube. This is part 2 of my 48 volt 4 amp power supply project. This is the part 1 in my previous video, and the main idea of this part 2 is to detect overcurrent and protect my linear amplifier. So let's look at the block diagram. So this is the input. So input of this portion and actually output of my power supply. This voltage divider is to read with ADC the current voltage. So with this setup, 48 volt will give around 2 volt, which is well inside the range of my ADC input, up to 3.3 volt. So this is for voltage, and another ADC pin is for current detection, and we are using this current sensing module INA, based on INA 169. It can be used up to 60 volt and has the module comes with a 0.1 sense resistor, and load resistor, it comes with 10K, but 10K, using 10K is the output will be 1 volt per amp. So in our case 4 amp, for 4 amp we will have 4 volt output, which is well above my ADC range. So I changed it to, I have to remove this load resistor here, remove this one, and then mount a new 6.8 kilo resistor here. So with this, 4 amp will output 2.7 volt. So even up to 5 amp, it should be okay. But well before reaching 5 amp, the device will cut off the bias current of my linear amplifier, so it will never reach 5 amp. So this is a sensing resistor and output load resistor, and the data sheet INA of INA 169 recommends to use op-amp as a buffer, and this is a low pass filter. This is just DC output, so I can use this as kind of protection to my ADC pin. And the microcontroller used is STM32F411, and this one is also known as blue pill, and can be purchased from AliExpress. It's only a few dollars. And here we use ADC 2-channel input of ADC, one for voltage, one for current, and this GPIO output is for overcurrent alarm output, and these two pins are used for I2C display. So we use SSD 1306 based OLED display. This is the display for 48 volt for voltage level and then current consumption. Originally I was thinking to put this MCU and INA 169 inside the power supply unit, but couldn't find a place to put the display. And I was also worried about this alarm pin, alarm signal going, like if it becomes, like if the power supply is far from the linear amplifier, we can have kind of noise over on this line. It's only 3.3 volt output, so I decided to put it in the external box, close to the linear amplifier. So where was I? Yeah, and this overcurrent protection, it can be actually, if this module goes inside the power supply, I can simply pull this pin, adjust pin to ground, and that way the output voltage will go down to 1.25 volt. So it will prevent the linear amplifier from damaging this FET. But the final decision was to use, this is a schematic diagram of my linear amplifier based on MRF-101, and it has this bias off input. So if I put a high level, TTL level, 5 volt or 3.3 volt, it will cut off the bias, and so the amplifier will stop working. So that's the choice I made. So this will go into here, but because I already have one pin connected to this bias off, it's actually during PTT, if PTT is closed, then this pin goes low, and if it's open, when the amplifier is not used, it goes high. And this is for next stage amplifier PTT control relay. So I had to use a OR gate. So if any one of, so this PTT control, and this is overcurrent, if any one goes high, it will output high. And I had at hand this NAND quadruple NAND IC, so I could use three of them, and you make an OR gate out of it. So but this one has 5 volt TTL level input, because it will be supplied, the power supply will be 5 volt. It has the output of my STM32 is not enough. It's barely enough. So this pin, I set it up to open drain. And then the input will be pulled up to high. So when it's high, it's pulled up to high. When it's low, it drives it down to ground, to low level. So that solves the level difference. So did I cover everything? So INA 169 voltage divider and STM32 F11 MCU, and this is OLED display. Yeah. By the way, this can be purchased from Adafruit for this price, and this is clock setup using 25 meg oscillator on board. I think that's all I have to say about this project. Thanks for watching. 73.